100 kilodalton protein is run under reducing SDS page, what should not be possible? So they don't tell us anything about this protein other than that it's 100 kilodaltons. For example, it could be a single monomer that's 100 kilodaltons, or it could be a homodimer made up of two 50 kilodalton components, or it could be a heterodimer made up of 40 and 60 or 30, 70, whatever the case may be. They don't tell you that, so you have to just see the options and see what could match up to this protein. All right, let's elaborate on this though. If you take this 100 kilodalton protein and you run it under an SDS page, you're going to get a single band at the 100 mark. Now let's look at this one right here, this 50-50. Pretend that this bond right here is non-covalent. What you're going to get if you run it under a regular SDS page, so not reducing, you're going to get a thick band at 50. Why? Because the SDS, sodium dodecyl sulfate, that denatures the protein and breaks all of the non-covalent bonds. How about if this was connected by a disulfide bond? The SDS alone is not enough, so you would actually get a band at 100, just like this one right here. Now we're dealing with reducing SDS page. So let's just make up molecules and see what matches up to each of these. The first one band at 100 kilodaltons, we just showed that right here, right? It doesn't matter if you're native SDS or reducing SDS page, this one is always going to show up as 100 because it's a single piece. So it doesn't matter if you denature, it's the same size. Next, let's look at C. One band at 30 and one band at 70. This would be a heterodimer that's combined by a disulfide bond, just like we showed before. It's just that the sizes are different, so 30 and 70. The reducing aspect, like beta mercaptoethanol, that would break this up and give you one band at 30 and one band at 70. Next, D, one band at 25 kilodaltons. This is definitely possible. It just would be a thick band, right? How is this possible? If you have a homotetramer, right, and all of these are combined by disulfide bonds, if you do reducing SDS page, all of these will break up and you'll get each of these individually, right? Each of these is 25 kilodaltons. So all of those will show up right here, except instead of being a thin band, it will be a thick band because there's many of them, right? Leaving us with B, two bands at 50 kilodaltons. You might notice that you could have answered this without even understanding whatever I just talked about, because this is not possible. You can't have two bands at the same size. It's just that you'll have a thicker version of a single band. So this is our answer.